Welcome to today's lesson on zeros of a polynomial. In topic 1, we're solving quadratic equations using two methods, the square root property and also by factoring. The square root property can be applied on numbers 1 through 6. If we look at number 2, we could factor this quite simply into x plus 7 times x minus 7. Or, if we recognize we only have an x squared term, the square root property would say to set x squared equal to 49 by adding 49 to each side of the equation, and then to take the square root, remembering the plus minus. Then we would get two solutions, a positive 7 and a negative 7. We would do the same thing on number 6. Trying to isolate the x squared by subtracting the 27 off of each side of this equation, then dividing by 3. Now when we take the square root, remembering the plus minus, we can determine these values by using the imaginary number, resulting in a plus minus 3i, again where we get two solutions. So remember, the square root of negative 9 is the same as the square root of negative 1 times the square root of 9, which is I times 3, or 3i. Numbers 7 through 10 are really just taking out a greatest common factor. So if we look at number 7, we have x squared and x. That's why the square root property does not apply. We can take out a GCF of 5x, leaving behind an x minus 3. Again, here we would just take each factor, setting them equal to 0, resulting in our two solutions of a 0 and a 3. Let's scroll down into topic 2. Here we are still solving. Now we're solving trinomial equations by factoring. So remember, a trinomial has 3 terms, and in each of these trinomials they are set equal to 0, which is a requirement before factoring. Number 13, we need to factor this, and the leading coefficient is not 1. Therefore, my method for solving is to set this up as an x plus something over 2, x plus a fraction over 2, equaling 0. My 2 comes from this leading coefficient. I then build a table. I take the product of the first and last numbers, 2 times 2 is 4, and then the middle coefficient is 5. I look for factors of 4 that add to be 5, which is the 1 and 4. I put the 1 over the 2 and the 4 over the 2. In reducing or simplifying these fractions, I get an x plus 1/2 and an x plus 2. Anytime I have a fraction remaining, I fix this problem by pushing the 2 up in front of the x, resulting in a 2x plus 1 times x plus 2 equaling 0. Now I set each factor equal to 0, resulting in solutions of a negative 1/2 and a negative 2. I'll practice this again on number 14. My leading coefficient is a 6, so I start with an x plus something over 6, x plus something over 6. Still an equation equal to 0. I build a table where I take the 6 times the negative 2, which is the negative 12, and then the middle coefficient of 1. I list factors of negative 12 until I locate a set that will add to be 1. That set would be a negative 3 and a positive 4. I place the negative 3 over a 6 and a 4 over the 6. I now reduce or simplify these two fractions and then push the denominator up in front of the x, resulting in a 2x minus 1 times a 3x plus 2. Now that it is factored, I set each factor equal to 0, resulting in my solutions of a 1/2 and a negative 2/3. Moving on to the next page, we can also solve a quadratic equation using the quadratic formula. When we do this in this section, you need to prepare to include the imaginary number. Looking at number 17, again using the quadratic formula to solve, my A value is 2, my B is 5, and my C is 7. So my solutions will be x equaling a negative b plus minus the square root of that b squared minus 4 times a times c all over 2 times a. This becomes a negative 5 plus minus the square root of 25 minus 56 over 4. This becomes negative 5 plus minus the square root of a negative 31 over 4. We don't want to leave a negative under the radical, so we will change this to an I in front of a positive 31 under the radical. These will be our two solutions to this quadratic equation. So again, in this section, prepare to see the imaginary number surface often when you apply the quadratic formula. Let's look down at number 19. This is multiplying a trinomial times a trinomial with the imaginary number involved. When I multiply using distribution, I will result in 9 terms. So there's no high level of difficulty, but it does require accuracy. So I'm going to multiply the x times x, the x times negative 3, and the x times a negative 4i. Now I'm going to change pen color and multiply negative 3 through, resulting in a negative 3x, a positive 9, and a positive 12i. Now I will change pen color again and multiply through times 4i. Now all I need to do is combine like terms. So I have x squared. I have a negative 3x minus 3x, which is a minus 6x. I have a 4ix, a negative 4ix. Those add to be 0. I have a 12i and a negative 12i, which add to be 0. Then I have a plus 9 and a minus 16i squared. We need to remember that I squared is just equal to negative 1. So now I have a negative 16 times a negative 1. Then my result is the polynomial x squared minus 6x plus 25. Often when you multiply these trinomials, your imaginary number will be absorbed in the process, so your answer is only real numbers. I'm going to close this recording here and start another recording for the connection to college algebra.